mechanistic interpretability of the neural network through the interval analysis. Professor Karras, having the 25 years of experience, he is a rich academician as well as researcher. He has a global rich profile and network. He served as a several journal editorial board and a member of governing member of several universities and uh, research society. He is an active academician and professor. His expertise in the field of machine learning, neural network, signal processing, image processing, and computational intelligence. Over the past 25 years, he is actively working with this field, and currently he is a professor of KNKUA Greece University. It's a European oldest university, and and he is a renowned professor. He has having the several profile of the university as well as other university also. He always ready to with us for a call or for any special invitation. Professor Kras, I am especially associated with him since I think 5 to 10 years back, and since that I am associated with him. I think, sir, we have a 6 to 7 talk with me. You have already done with me, and you are a great accommodation, sir. And thank you very much for inviting my, accepting my invitation, and always ready with me. And thank you very much, sir. And I think I'm fortunate to have a friend and professor with you. You are closest to me. You are always ready to me for me. Any type of help I needed, I always call to you. You always be ready and with me. You support me always with a positively. And you are a very positive professor, active, specifically in the age of this, having the 25 years of experience. You are proactive learner. You are a academician who move with the latest technology and forward learning process, right? And thank you very much, sir. I think I should not take more time and should hand it to you. And thank you, sir. Thank you. Welcome to here in India. And I think we will meet in the February 1920 in the my conference as well, physically. Thank you very much, sir. Please, sir, hand it to you. Please start your session, sir.
Thank you. So, good afternoon from here. It's evening in your side. I'm very glad to be here with you. I thank Professor Satya Prakash for the invitation and the introduction. This is one of the meetings we have since the past, but as Satya told, I will be with you physically, not with Zoom, in 19 and 20. I come in India 18th of February, and I will leave 21st of February. So we will be there to see potential collaboration for several things regarding AI, mainly because although I am involved in several things about AI, signal and image processing and system engineering in general, including web engineering, safety systems, etc. My main involvement is in AI and its applications, theory and applications of machine deep learning and artificial intelligence. So today, starting with my session about mechanistic interpretability of neural networks, I want to introduce you with an active field, very active field of research, mainly in mathematics, but its applications, this is my concern, its applications in AI and machine learning. AI and machine learning for what? Okay, mainly here I will explain things about pattern recognition. But of course, interval analysis and the relevant techniques can be used in a series of fields, including regression analysis, time series, and whatever. But we will see about pattern recognition today. So, an overview first, what we will see here. First, an overview about uncertainty. Not everything about uncertainty is a big issue. After an overview of current techniques, excluding fuzzy logic for certain reasons, because I don't have time for this, we will see interval analysis and how interval analysis can be used in the interpretability of neural networks and research in neural networks. This will be the main topic. But first, in order to understand why interval analysis and no other uncertainty methodologies, because the topic is we have uncertainties in neural computation. This is the major thing, and I will explain why. Actually, the real world is full of uncertainties. There are certain sources of uncertainties and inexactness. So how we can reason through uncertainties? This is a big question. So we have inexact knowledge, we have inexact data, we have inexact measurements. All these are inexact. We think we are exact, but we are inexact. And of course, there are missing values everywhere. The data, training data in neural networks is a big issue. How to guarantee that the data are fully correct, fully reliable, etc., fully calibrated. This is not an easy thing, and therefore uncertainties are introduced everywhere. So there are methodologies, of course, in the literature and in the research in order to handle not a fully deterministic world, because the world is not fully deterministic. I can explain this because you all know quantum mechanics, and quantum mechanics is based on probabilities. It's not based on deterministic functions, on Newtonian mechanics. Newtonian mechanics and general relativity are based only on deterministic structures, deterministic functions. But the real world, starting from quantum mechanics, is full of uncertainties, and I don't mean only the Heisenberg uncertainty, I mean uncertainties in everything. So we don't have a simple function and say that's all. No, it's not like this. We had, from the beginning of AI, several methodologies. For instance, MySyn, the first AI expert system in medicine, it was based on belief theory. I will explain this, but shortly, because this is not the main part of this session. So even from the beginning of AI, we had the issue of how to introduce uncertainties and measures of uncertainties. So reasoning under uncertainties is an issue of over 60 years, maybe 70 years, and the reasoning under uncertainty. We have heuristics, of course. We have certain empirical associations. We introduce probabilities, we know this. And also, we have fuzzy logic with membership functions. Because fuzzy logic is for another session, it's a huge issue. I will not devote this session in fuzzy logic, but in things like belief, because it's a good way to handle uncertainty, and Bayesian framework in order to go to the interval analysis framework. So what we need is, of course, expressiveness. Therefore, the major issue is how to represent our data. When we are talking about uncertainty, is how to represent efficiently our data. And interval analysis, as I will explain, provides such a capability. Comprehensibility is another characteristic that we need in order to reason with high utility of our data, and therefore, again, is correlated to representation. Representation is the core aspect of how to handle data in neural computations. Correctness is a major issue, of course, on how to handle our data. Because correctness, if we don't believe in correctness of our data, how can we believe in the reasoning, in the results, let's say? And also computational complexity, these are characteristics, and we will discuss about computational complexity of these models. So the sources of uncertainty first come from data. It's not the only source. We have also the algorithms, but let's say first data. We have missing values. We know this. We have unreliable data. The measurements are inexact. We cannot guarantee that even precision measurement is precise in accuracy of 10 minus, let's say, 20. 10 minus 20 is impossible. 10 minus 6, 10 minus 8, okay. For Newtonian mechanics, this is enough. But is this enough for all real-world problems, especially if we have complex systems? Because any inaccuracy, you know, is propagated. Any inaccuracy is propagated. And finally, we have big uncertainty in complex systems. In networks, for instance, computer networks, can we measure and predict, especially exact delays in huge networks? No one can predict. There is uncertainty. So data in general give uncertainties. Representation. How to represent data? Okay, we know in NLP, for instance, we have the word embedding, the one-way hotshot. We have certain methods in order to represent data with bits, bytes, real numbers, whatever. Bits and bytes, it's, let's say, the digital type of accuracy, but the real world doesn't have bits and bytes. You know this, we have real numbers, and maybe not only real numbers. We may have to use R powered n. Therefore, we can even involve not only real, but complex, and not only complex, ternary numbers or whatever. So you understand that the representation is imprecise, might be inconsistent, subjective in categorical data, and categorical data is subjective, is full subjective. But it's not only the data, it's also the expert knowledge. Can you find two experts with the same opinion exactly? No. Go to medicine. You have teams of doctors. Can the team have one and only one opinion? All? No, it's impossible. The decision is made, of course, by different experts through majority rules or whatever after discussions. So expert knowledge is not something very accurate. It depends on the expert. So no one holds the truth in events that are difficult to explain. Okay, if there are some symptoms, there are many ways to interpret the symptoms. So depending on the knowledge expert, we have good and bad, let's say, or medium accuracy expert, let's say, decision. So we want here, in order to guarantee equality, we want some measures like plausibility, like probability. It's not possible to label the data so easily. You understand, in neural networks, one of the problems is not only calibrated input, but also correct labeling of the data. Okay, how do you know that the label is correct, fully correct? Another expert might see this different. So we understand the uncertainties in the quality of data. Knowledge representation, therefore, is a big issue. We had knowledge representation from the beginning of AI, and this beginning was done with rules, crisp rules, and the knowledge representation could be effective through Prolog, Lisp, and other languages, given numbers and, of course, bits and bytes. So the inputs always were real numbers or digital representations of the real numbers. The inference process, do we have uncertainty in the rules? Yes. In complex systems, it's not clear which rule should run. So in expert systems, reasoning is not so easy to say if A, B, if B, C, if C, D. It's not so easy. We may have certain rules that are matching. And therefore, there are rules in the inference engine, which is a big part of AI, classical AI, in order to run. But this is deductive, the productive reasoning. For the neural networks, as you know very well, we have inductive reasoning, and this means reasoning from data. I can say clearly that all this approach of inductive reasoning is not human-like intelligence. It's stochastic parrot, let's say, intelligence, is a type of pattern matching. Actually, our neural networks work well trying pattern matching. Even in transformers, now GPTs, etc., we use actually pattern matching, nothing more than this. So inductive reasoning is actually generalizations of pattern matching. How? Through samples. So we collect samples, we know very well this issue, and we try with these samples to build the real problem world in order to have generalization capability. These are known things in neural network application and theory. But we have some uncertainties here. One of the uncertainties is the sample size enough? Okay, statistics, we have statistical tests to inform us whether a sample is representative or not, as a number of samples. But it's not so easy when we don't have enough samples. And in the majority of cases, we don't have. For instance, cancer data. We may have a lot of samples and benchmark databases, But are these enough to cover the whole world of cancer cases? All these introduce uncertainties. And the uncertainties, even in the rules, imply that we have domain errors, representation errors, inappropriate application of the rule. So nothing is so simple as we take a benchmark set, let's say data set, and let's apply our models and see, okay, what happens here. We are efficient with good accuracy. This is what I see in papers. What I see in papers as editor-in-chief in several journals, including Scopus. What I see is actually many, hundreds of papers without any questioning about the data. I take this data set and I apply my model, combination of models, let's say, and I say, okay, very good accuracy, very good AUC, ROC curves, etc. It's not like this. Very few people understand the problem of data and algorithm application and inaccuracies. All serious journals want to see how you think about your data, how you deeply see your data. So is your sample representative? You should discuss this. Are there errors in your calibration? Are your data calibrated fully? Can you believe in this data? All these are big questions, not very well answered in the majority of papers. So we should be more deep in our thinking about how we apply neural networks, in what kind of data, and how we are sure about our results. This makes sensitivity and reliability a must for any paper. Without, in my journal, let's say, one of my journals, Interdisciplinary IGITIS, Journal of Interdisciplinary Science and Technology, a Scopus journal, I ask always reliability and sensitivity of the results. Otherwise, I cannot accept a paper without an analysis of the data and the results. It means not good thinking, not thinking in depth in the area. But it's not only, as I told you, in complex systems, we have the problem of conflict resolution. So we may have multiple rules, and these multiple rules have the problem what to apply and how to combine the application of the multiple rules. It seems not very easy, and it's not very easy. There is mathematical framework for conflict resolution at some, let's say, point of accuracy, but there is some such framework. But we have fuzzy logic, which is more relaxed in the conflict resolution. And of course, neural networks, the workhorse now of AI, doesn't have conflict resolution problems because this is done in the black box. How it's done, we don't know exactly. Also, when we have database with rules, do we have compatibility? Okay, we may have conflict resolution, but compatibility. And this means, are there contradictions between rules? Redundancy, missing rules, how to do data fusion. All these are parameters of uncertainties. We all know that in order to handle uncertainties, we need probability theory as one of our weapons in the armament of tools for uncertainty representation. We know what is a probability, as with the axioms of probability, we know very well. I don't have time to be in all these things, but only as in short. So we know that probability is between 0 and 1, expressing the plausibility of an event. So we are talking about an event space, and probability of any event should be given in order to proceed with joint probability of two events, of union probability. We can see also known things from the theorems and the axioms of probability. We know independent events. So if A, B dependent, then we have the multiplicative rule. In any kind of events, we have such a kind of a rule. So we have rules in order to find out the probability under operations, any kind of operators of events. So we have events and operators over events like this, joint, union, etc. We may have conditional probabilities, and we use this in our mathematics for AI. So A event given B event, we know, and of course, we have advantages and disadvantages. In short, the major advantage is a concrete mathematical framework, formal definition, but the problem is we don't know how to assign probabilities. They are subjective. We may have ignorance. We may have non-proportionality in complex systems and complex statements. And of course, we cannot assign easily probability distributions. We assume always in the probabilistic framework Bayesian normal distribution. So Bayesian approach is prevalent in uncertainty representation, even in neural networks with Bayesian or belief networks. We have probabilistic neural networks, etc. What is the most important aspect of the Bayesian theory is going through the Bayesian theory. It's about what is the probability of a hypothesis under an event. So I have an event and I want to test the hypothesis. So the event is that exists, for instance, an anomaly in human body. Is it cancer? This is the hypothesis. I have cancer. Is this event showing cancer? So we know the Bayesian framework. This is the well-known Bayesian theory. And we can also involve in this way or other ways the Bayes rule of a single event. So we have certain events, we have the end hypothesis like this, so multiple hypotheses and multiple events. And we try to find which is the probability, this is our task, which is the probability under that events E1, E2, etc., are true, which is the truth of any hypothesis HI. And we can calculate this through Bayesian theory, which holds these entities, the dependent probabilities of events under hypothesis. So if hypothesis is true, what is the accuracy of finding E1? This gives us the probability needed in order to find out the probability, the inverse probability. So inverse reasoning in order to find out what is the truth of a hypothesis when events happen. And the opposite, this is under a hypothesis, like we have cancer. What is this anomaly? What is the probability of such an anomaly if we have cancer? So you understand the inverse of the Bayesian rule. It's a very beautiful framework. So some theoretical, of course, foundations, but the problem is we don't have probability distributions known. We use normal distribution or Gaussian distribution. Of course, if we know the probability distribution, Poisson, for instance, we can have good accuracy. But it's never so easy to find out the probability distribution. So in neural networks, we don't have the problem because probability distribution is developed through the data. We have, however, certainty factors, another approach. Certainty factors were used in expert systems like Mycin, and we can define like this. This is the belief. So in certainty factor theory, we have belief, disbelief, and certainty factor. We first define belief, and belief is considered like this, or if the probability is the certain event, then belief is 1. Otherwise is this. So depends on these definitions, what is a belief of a hypothesis. The certain factor is belief minus disbelief. So we built another theory with certainty factor theorems, and we have certain axioms, theorems, etc. It's more relaxed than the probability theoretic framework, and is connected to evidence theory. So there is association, of course, between probability and belief, disbelief, and certainty factors. You can see here, no evidence, certainly false, certainly true, etc. So the ranges are the same from belief, disbelief, and probability, but for certain factors, you can see it's between -1 and +1. In any case, this certainty factor theoretical framework is more relaxed than probability framework, doesn't need, it's more empirical, doesn't need probability distributions, and it's because it's empirical, it's easier to gather. We don't need to build the probability distribution with many experiments, etc. samples. So it's a bit ad hoc because it's empirical. All these factors are empirical. The Dempster-Shafer theory is the most concrete implementation of the certainty factor theory, and we have a more important and more complete framework that includes environmental variables, the frame of discernment, mass probability function, and values. And in this framework of Dempster-Shafer, we define plausibility, certainty, belief, etc. So the principle is to combine mass probabilities, as here. We can have already this correlation between probabilities and Dempster-Shafer mass probabilities. We are talking about mass probabilities and probabilities here. You can see the relations. So evidential reasoning is done through Dempster-Shafer theory. We may have an introduction here of interval, evidential interval, So we don't need the very strict probability value. We can be within intervals. And this is also an introduction why intervals are so important, because we will talk about interval analysis in 5 minutes. So the advantages is that we have a mathematical foundation, very good and intuitive mathematical foundation, but the problem is the determination of mass probability is again, although based on empirical approaches, it's not so intuitive as in fuzzy logic, for instance. It's highly computational demanding. So although probabilistic framework is not computation complex, Dempster-Shafer evidential framework is too much complex, and the usability is not clear. It's difficult, although beautiful framework, is difficult to be applied. Now evidential theory is not so well applied in problems, let's say, of everyday practice. We don't use it. So the applications of these frameworks involve these terms: Bayesian networks, certainty, belief, disbelief, inference, etc., ignorance, knowledge interpretation, probability reasoning, all these things that we discussed so far. So we come to the major thing, which is why and how to use interval analysis for uncertainties in neural computations. First of all, why we have uncertainties in neural computations. As we talked before, we have uncertainties because of the data. So ambiguity of the data, missing values, noise, sampling errors, measurement errors, and so on. But we have also uncertainty due to the algorithms. So on how to apply the algorithms on the data. So processing of the data has uncertainties. One major uncertainty, because we will see this, is initial conditions uncertainty. You may know very well that in any, even deep learning algorithm, we start from random values. The weights, all weights start from random values. So initial conditions is a must to check. I will tell you why initial conditions are so important with a work that we present here immediately after these motivation issues. But also, we have architectural and structure of the neural network uncertainty. So when I see a paper as editor-in-chief, when I see a paper without any thinking, any problematic, let's say, any discussion about architecture, about data, about algorithm and application in the problem, I am sure that the person, the researcher, has not understood the real complication of what is the application of neural networks. So when we say about mechanistic interpretation of neural networks, uncertainty is a must to include in your discussions. You should be very skeptical when you apply. Why I apply? How sure am I about this application? But it's not only this. It's also uncertainties about the limitation of the space of feasible solutions. How sure we are about our feasible solutions? And here comes a major thing that I will refer in the end of this talk, which is the validity of the results. So our results are valid, a big thing. How to manage this uncertainty in neural networks? How to manage uncertainty in neural computations? We have structural uncertainties, and the structural uncertainties have to do also, of course, with architectures, etc. And structural uncertainties also include initial conditions, hyperparameter values, operating limits of the neurons, and so on. Also the methods. So it's not only data architectures, it's always the process, the whole process of setting up the neural network. So here is the big uncertainties. The initialization, of course, of the weights, optimization of the architectures, efficient and optimized training in order to find, if possible, global optimum. Another uncertainty here, we never find global optimum. We find only local optima. And the validity of the results. These are the most important uncertainties in neural computation, in neural networks, and these are actually what characterizes as important the application of methodologies handling uncertainties. One of these methodologies is the so-called interval analysis. So the interval analysis, as I introduce here and in some more transparency, is only to give you the concept. I will not give you all mathematical details, but interval analysis is based on interval arithmetic. And this means that the problem can be transformed from non-linear to linear, to system of linear equation, but interval equations. I will present this. So the algebraic solution is the solution of an interval linear equation. We don't solve non-linear equations of intervals. We don't need non-linear. We need, however, how to solve interval linear equations. This is a concrete mathematical framework in a field of mathematics which is called interval analysis. We need also the so-called set inversion, how to inverse problems, as we will see, in order to check the validity. So we have functions. I will introduce this very short in 1 minute. We have interval functions, and we go from x to y to go also from y to x. So this is the set inversion problem. But let's talk a bit more concretely about how to perform interval analysis. First of all, we have interval numbers. Any number can be an interval number, like this. It's an inclusive interval, not open, it's a closed interval. X. And of course, x is a real number. We can introduce here, with such intervals, we can introduce all basic operators, like set relations, like a set. This is like a set. So we have union, section, inclusion, etc., etc. We have also other basic operators, like width, rand here, median value, etc., mid-interval, arithmetic operators between intervals. So I can subtract, I can multiply, divide intervals. We have monotonic inclusion between intervals. So all operations, or nearly all operations, of set theory and number theory can be applied, of course, with care and with extreme care in the interval analysis problem. However, it's not only for numbers. It's also, we can extend to arrays and matrices. So vectors like this. This is an interval vector where each component is an interval. We have interval matrix. You can see an interval matrix as a function in R square n. As you can see, R n m actually. We have also inclusion functions like this. You can see a function from R square n to R square m. So and m. And what happens here? You see, I can have either interval definition of the function or a function of intervals, or even both, interval function of intervals. How to interpret, however, without the mathematics, how we can interpret? We have here, let's say, an interval like this, which is this pattern, and through the interval function, we have a representation in the y space, and the y space, you can see, is this area here. So through the interval, we get another interval, even if the function is interval or is a function of intervals, we go to another output interval. But there are problems in this. The theory is good, but we have some problems, and see here the problem. I have an example only. It's the functional dependence and overestimation. So you see two functions in order to understand the problems of interval analysis. I have this function, therefore, and I want to build this function through intervals. I may have, you can see that this is the same thing, obviously, in algebra. So I may have it as a generalization in intervals. So instead of x is an interval now. And this is the interval in this term. You can see that 0, 2 minus 0, 2 interval squared, because 0, 2 square makes 0, 4. 0, 2 times 0, 2 makes 0, 4. But if I apply this subtraction, I am in minus 4, 2. If I apply to this function the interval, now I am in completely different calculation. So we understand that intervals have a kind of problem of overestimation or dependence, giving different results. So there is no only one result for the same function. If I write differently the function, I get different results. But when I say different results, you can see that here is minus 4, 2, but here, if I draw this down, is minus 2, 2. You understand that the minus 2, 2 is inside minus 4, 2. So you understand the problem is not exactly that we get different results, but we get inclusion intervals, overestimated or underestimated. So this might cause some problems in our interpretability, of course. But what happens in this framework on how to train and how to apply such framework to train? First of all, I want to ensure you that we need interval analysis. In only 5 minutes or 10 minutes, I explain how we did this weight space analysis for multi-layer perceptrons. So what we do, in short, because the time is limited, is we want to analyze the weight space of neural networks. And the critical issue here is, where is the solution? Which weight space set guarantees solution, and which weight space area is not a solution? So what we get is we randomize weight space, so we randomize all weights in order to get the full weight space, let's say. And we get solutions and no solutions through the whole space. How to represent such cases? We represent this, for instance, in order to understand the work, we represent this using clustering analysis of the weights, but you know, the weights are thousands. How to cluster this and display this? We have some self-organizing feature map of cohorent. So what we get is the topology, because you know, some maps get the full topology of the multidimensional space, n-dimensional space. This is what we get. In the 2D space, we get the n-dimensional space topology. What we do therefore here, we want to map in this full space of weights, because this is the full weight space, we want to get where are the solutions, where are and how dense is this space. So we make experiments for the iris, the Fisher problem, and we get solutions and no solutions. So what we get here, because these are the cells of the self-organizing map, as mapped in the 2D, we see that all solutions are inside the cells, and all no solutions are in the borders of the cells. This is a concrete result already published during 2011 or 12. Also, we noticed for different architectures you see here, 4, 10, 3, etc., how to do when there is uncertainty for the exact point in the space. So if I introduce noise, what happens? You see, perturbations, small perturbations, might result in no solution. So small perturbation of the weights, the initial weights, okay, these are how initial weights are connected with solutions of the classification problem in this case, which is the iris, the well-known iris problem. So you can see clearly here what happens. Small perturbations lead to no solutions. Okay, I will not explain the full contribution, but you understand what is the important thing here. The important thing here is that even small, so perturbation could be represented by what? By an interval. An interval, so not a crisp number, it's not the issue that I'm here and only here in the initial weights I will get a solution. No, even a small perturbation might give, or in another interval here, the previous interval, you can see small and goes to no solution. But here, a small perturbation might lead to a solution. So what is critical here? To find the interval where we have solutions. It's not the important thing to say, in this exact point, I have solution. So we get this in order to introduce how to use interval analysis for the initialization of the weights. We discussed about the uncertainties, we discussed about the unsuccessful selection of initial weights. Unsuccessful means we get to the borders like this. We get to the borders. Successful means we are here inside the cells. So we know, we can calculate where are these successful weights. But we have also other points that are critical for network training. And what is the critical point in multi-layer perspectives? In other networks, we have other points, but in multi-layer perspectives, we have the problem of saturation or insufficient activation of the neurons. What does this mean? This means that our neurons, I don't have a graph, but I hope you all know the sigmoid or the tangent function, where for a small space, we are in the linear phase, and then we are in the saturation phase of the activation function. So the saturation or the insufficient activation gives problem with converging to local minima. So what we want is that the neuron is activated in the linear phase. This is the reason you know very well that the initial weights should be near zero. But how near zero? Because if we are in zero, we have delays in the complexities in the training of the neural networks. So based on the initial weight, we may introduce false local minima or stray hidden nodes, also duplicate hidden nodes doing the same work. So here we need a formalism in order to avoid such conditions of local minima and insufficient activation. And this is the known formalism even for the sigmoid or as here in the signum function. By this we mean sigmoid here, but you could use also the sigmoid function. So the activation of a neuron, Y, is based on the inputs coming from the previous layer, and of course the weights, the bias, this is the bias weight, and these are the aggregator linear combiner of weights and inputs from the previous layer. So you know this, and you know that this sigmoid function, it's a linear and non-linear phase, linear in the beginning, and then after a while it makes a curve to saturation. So what to do with this? How to ensure that we can transform such a requirement to be mostly in the linear phase, in the initialization. So we build this formalism. our weights should be between a parameter A minus A. So as an absolute value, we should be, and this is an interval, of course, minus AA is an interval. So this is the interval. And what we want is that the activation of the neuron, because this is the aggregation with the bias, we need this to be within the linear phase. This is the important thing. This is the nonlinear because of the sigmoid. But sigmoid works well when we are here in the interval of the linear phase. This means a constraint for our equation to be the neuron active in the linear phase. So, after understanding this formalism, we built the so-called interval tolerance problem. The interval tolerance problem makes for all neurons to activate, to be active, only in the linear, only in the linear space of the activation, in order to avoid saturation, because saturation makes us go to local minima and difficult local minima, flat points where the gradient does not exist. So this is the big issue, and we try to find out through such here an interval system. Based on this analysis, we built an interval system like this. And the solutions, we can find the solutions because there is the interval tolerance problem solution given in mathematics, and we apply this solution and we find the best points, the best intervals, not points, not crisp points, intervals. So this is, the weight should be in the interval minus AA, but we find out that should be modulated by this factor. And this factor, you can see, is normalized factor for based on what? Based on the maximum of the input space, maximum of the features. So we found out the interval tolerance solution as the best solution in order to have very good initial weights based on this formula. And we made a series of experiments. This has been published in 2018 in Neural Networks journal of Elsevier and Neural Network Society. We experimented with all available frameworks for initialization of the weights, Boris and Kuiper, Botu, Kim and Ra, etc. And what we found as a result of this work is that this approach, the interval analysis approach, is better at least 15 to 20% than all these methodologies. So we have done, of course, series experiments, not only in UCI, not only in other, but in nearly every benchmark similar to UCI and bigger, especially in more complex problems than UCI, because UCI repository doesn't have the most complex problems. So we did also in Atlas for magnetic resonance, MRI images, etc. So what we had to see in through ANOVA analysis is that we have a 15% improvement, at least 15 to 17 in all problems with this methodology. But as a last part of my talk, I want to introduce you a methodology for the validity of network training. And then we can discuss about these issues. So, validity means the inverse problem. What is validity? Validity means, for instance, what the doctor wants. You present to the doctor a network, a neural network, and you say, this is working. How it's working? How the doctor can trust this network? In order to trust, the doctor should expect specific things. We don't want to have unpredictability. This is unpredictability in the results makes our trust zero, makes our trust zero in the method. So we need to trust. Trustworthy AI could use such a kind of analysis, interval analysis. Of course, it's in a preliminary phase, as you will understand very shortly. So what we need here is to know which areas of the input space lead to cancer, for instance, lead to non-cancer, to normal cases. So we need an input space analysis based on the evidence, cancer, non-cancer, is something, as you understand, like Bayesian probabilities, Bayesian a posteriori probabilities. So, what is, if we know we have cancer, what are the input space data that led to this? Which are the intervals, therefore? We can, therefore, analyze the input space through intervals. It's very difficult to analyze otherwise with numbers, but with intervals, we can analyze. So, which are the input data where the network shows specific outputs? This is the problem. So, I have a network, X input, okay, to Y output space, N to M, Rm, Rn. Rn is the input data, Rm is the output space. So we have already a function f, which is implemented by the network. So an MLP, for instance, is f, and it's a function of the input to the output. In order to understand and analyze the inverse problem, I want, and I know Y, I know space Y, cancer, non-cancer, and I want to find the relevant intervals here. How to do this? We can do this through the so-called Sevilla algorithm. The Sevilla algorithm by Jolene and Walter is an algorithm that, given Y, inverses to X. It's an interval analysis problem. So it's like this. And the Sevilla is an algorithm in order to associate output space to the input. This is the algorithm. I will not show details. I want to introduce you only to the concept and the results, of course, which are very good, as you will see. So the Sevilla is used in control theory, interval control theory, with success, but for limited number of variables. Here we apply in thousands of variables, so we extend CV algorithm, although it can be, but it's difficult to apply in, let's say, in millions of variables, as in deep learning. We need more computational power for this. But for thousands of variables, it's not difficult. But let's see the results, because this is the most important thing in order to understand the concept. So we have the contour map of a problem like XOR. We start from something simple. And we know the output space. We know that here, for instance, and here could be the category 1. Category 1 is 1, when output is 1. So we see here this interval, 0.81, this one, and this one, to 0. This is category 1. You remember the XOR problem. And this is the category 0. Of course, you can see very well that here and here we are near the 1, of course. Here guarantee 0, but there is uncertainty space here between 0 and 1. So these are the contour maps for the output intervals. And if the result is 1, this is the crisp result. But what we said is that we accept over 0.8, you see it here, 0.8 to 1 is considered 1. And 0 to 0.2 is considered 0. Okay, so this is 0 to 0.2. So the results here mean that this is, in order not to be confused, this is the input space, all right? And this is the space of the input that leads to 0. But what 0? 0 to 0, 2. This leads to 1. But what 1? 0.8 to 1. The remaining is not 0.002 or 0.81, but it's, for instance, 0.6, which does not belong to any category. This is the uncertainty category. So if we consider 1 is cancelled and 0 is normal, and this is the input space, whatever values in the input space are between this, we know that the solution will be normal patient. But if we are here in the input space between this area here, then the output is 0.8, 1. If we are here, the output is uncertain. Look, this problem, the ring spot problem. The ring spot has 2 categories. You see the samples, 1 and 2. What happens in the input space? In order to get 0.81, therefore category 1, this is the category 1, we get by interval analysis that this is the subspace of the input space that leads to category 1. This one, by CV algorithm. And this is category 2. You see that this is larger than this. So this is included here. So there is an uncertainty area. Another one with many, 2 classes, but several groupings, as you can see. Under such a network, trained network, the best it can do for category 1, you can see, actually is not like this, because you see, it's this, and this. But the best this network can do, so the doctor now, with this CV analysis, says, all right, my network is trained only to recognize these things. Only in these cases, I have some kind of recognition, category 1. For the rest, I'm unsure. But here I am sure. You see the trustworthy now. Another network, 281, gives this. You can see it's not fully okay, but somehow emulates the input space, the contour map in the input space for the categories. The 210 is better. Increasing the hidden neurons is better. And this is much better, you can see. Now, I'm confident that the 215 is near the reality, so the doctor is 100 or 99% sure that if I give points inside these areas of the input space, then my result is for sure category 1. This is the analysis of the input space through intervals. So the important thing in this analysis is that we have reliable determination of the validity field. We have actually quantitative estimation without any probability distribution hypothesis. We may found the probability of C, class C, under X. So the a posteriori probability of the Bayesian. And you can see that what we really find is this, because the CVIA gives us this. Input with respect to category, a priori, and of course, the probability of the sample. Therefore, we have an a posteriori probability based on the likelihood. Therefore, this here, input space contours of the CVIA analysis represents the likelihood function. So we have a way in order to find out the likelihood for our problem with regards to using an MLP, or not an only MLP, a machine learning, let's say, because F function is for any machine learning, SVM, etc., etc. So such an analysis gives us the likelihood. We have several published works in many journals, etc. And here I conclude my talk. Thank you very much for your attention. I'm going out in order to be able to see you. So the conclusion is that interval analysis has very good potential for neural computation, for classification problems in this case, but also in many other occasions. So it's a good tool for trustworthy AI. I tried to show you, to demonstrate to you some of the potential. This is an ongoing work, of course, and other results we will have soon to show through more mathematics of intervals. Thank you very much for your attention.
Yeah, thank you, sir. Thank you very much for all of your informative session. And you are really a nice delivery people. You have a nice style to speech and produce the thing what you wanted to do. It's a pure mathematical aspect of the AI, how it's work. And thank you very much for your such a wonderful session. And I would request to you, sir, could you please take some more question from the audience?
Yeah, of course, of course.
Yeah. So, audience, please, participant, please, if you have any question, so you may ask the question. Sir is ready to discuss.
And of
Yes, sir.
course, I'm open in any collaboration
Yeah.
with your institution for this and other. But we will talk more on this face to face when I come
Yeah,
to.
I'm welcome. I'm
I come
eagerly
there.
waiting for your physical welcome to here
Yeah,
in
yeah,
the
yeah,
Madan
yeah,
Mohan
yeah,
Malaviya
yeah.
University. We will meet soon and have a nice discussion with that over dinner. We will discuss there.
Yeah, okay. So the question,
Okay.
please.
Yeah,
Yeah.
please question. Ask the question, please.
So, sir, I do have one question.
Yeah.
So, like in modeling perspective, like if we do have, like available like evidence or limited, limited evidence or limited noisy, something like that. So, like how should we, like choosing the probability based reasoning and certainty factor based reasoning? So, according to that, how we will be, like deciding that which reasoning we have to choose?
Yeah, regarding the interval analysis, we don't make any assumption about probability, space, etc. So it's a clear mathematical formalism without its deterministic, but it's deterministic, but hardly uncertainty. In case of probabilities, however, and evidence theoretic approaches, in probabilistic space, we use the Gaussian distribution and normal distribution. We don't use other. But there are methods in order to define from samples what is the probability distribution. So there is theoretical method, but with limited accuracy. So if we don't know very well the probability distribution, it's difficult to find. This is the reason the interval analysis is a better way, not so, let's say, not so as fuzzy logic, very relaxed, very empirical. It's a more clear mathematical solution in the problem of uncertainty. So in fuzzy logic, for instance, you need to assign members, function, etc. Here you don't assign anything. Here you have the intervals. In the beginning, the intervals might be larger, but through processing, you may optimize these intervals. So there is no probability here, there is optimization of the intervals. This is the problem. Optimization of the intervals in interval mathematics is done by Branch and Conker and several other methods used also in graph theory. So we take parts of the intervals and we may have a brute force optimization. So here there is no any kind of probability. There is only brute force optimization. What does this mean? Computational complexity. So it's not everything very happy with interval analysis. We may have sorts of huge computational complexity and we need power. But now computing power is not something that we don't have. We have it. It's not scarce. It's an event. We can have such computing power for deep learning together with interval analysis and optimization of the intervals. So this is the big story. No probabilities, optimization of intervals. If you want probabilistic distributions, you go to Bayesian, you go to evidence theory, but then you should define the probability. Here you don't need to define anything.
Got it, sir.
Yeah, thank you, sir.
Thank you very much.
Thank you, sir. Is there any question from the participant? Because next session has to be started, and it's a really wonderful session delivered by sir. Anyone? So, sir, we could conclude. We really is thankful to your speech and accepting our invitation in a short duration. And I always appreciate your efforts. You always work hard and you delivered the session a practical aspect. You always try to do the practical aspect with the mathematics background. And I always inspired that I always get inspired by you that you are moving towards the technology. Your dedication, explanation of interval-based analysis technique to understand the internal neural network behavior, improve the transparency, and enhance the reliability, provided deep theoretical and practical insights. The session greatly strengthened our understanding of how interpretability can be approached from a regional mathematics from the structural perspective. Thank you, sir. Thank you very
Thank
much
you very
for
much.
your sharing and valuable time for us. Thank you
Thank you
very much,
very
sir.
much. Seeing you in India.
Yes. See you
Yeah, yeah.
soon in the February.
See you soon.
And we are here. We all are here, waiting to you to welcome and host to you. Okay. Thank you, sir. Thank you. Thank you very much.
Bye bye. Have a
Have a nice day,
nice
sir. Bye.
have a
Good night.
nice
Namaskar.
evening. Have a nice
Thank you, sir.
evening. Namaste. Namaste.
Namaste, sir. Namaskar. Thank you, sir. Okay. So the next session will be started soon. Dear participant, we will start soon after the 5. Sir, Ketu sir,
Yeah, sir.
yeah, could we start after 5 to 10 minutes or is there any more
It will
time?
take, I guess, we can start after 2 minutes. There's a
Ah.
quick break of 2 minutes and we will start after 2 minutes. We will start
Yeah,
at 7:32.
yeah. The participant, please stay here and have a take for the 5 minutes break, right? We will there again back for the next session, right? Regarding the PPT, we will share the all detail and information after the finishing of the FDP. We will share or update you on the WhatsApp group. So each and one who wanted to the PPT of his session, we will share you definitely. Please wait for the time. We will automatically share to you all the information of regarding the PPT. So it's our kind request to all of you. Please wait for that. Don't be get panic. We will share each session PPT to you. Even though we will share you the video also of the PPT. So I would request to all of you that please wait for that. Huh?
So
So it's
video
a
is
special
also,
question.
yeah, video is also available. That YouTube live streaming is happening here. So you can
Yeah.
also go and see the video over there. So there is a, for your reference, the PPT as well as the lecture is also recorded on the channel. So
That
we
will
will
be
also
posted.
share that. We will also share that. So you can make a reference of it if you are having some forgot or you have some problem or you have some understanding, you just forgot that particular concept. So you can recall it by watching that particular video.
Yeah. So I think Paul is here.
Yeah, Paul sir is
Professor
there.
Paul.
Yes.
Meanwhile, participant is there. So Professor Paul, I think you are there. You are hearing to us. Yeah. Hi,
Hello,
boss. How are
doctor.
you?
Hello, how are you? I'm good.
Uh,
I'm good.
I miss
So
your I miss your physical presentation in our conference. I
oh
really
yeah,
wanted to meet you in the
uh,
here.
I
again, but you
also
are still quite busy in your schedule nowadays, right?
I
And
also
hope,
miss to
yeah,
visit India
and hope
soon.
your family member are good right now, eh?
Yeah, yeah, yeah. It's already 10 p.m. in the evening today here in the Philippines.
Uh, so nice to see you, Paul. And
Yeah.
we had met Ketu sir. Ketu is my um,
Hello, sir.
colleague professor, and he is
Hello,
a
sir.
proactive professor, and he is a good speaker also. And
Wow. I
Ketu
love
sir,
to hear I love to hear him.
yeah, Ketu sir, Paul is my one of the oldest friend. He also
Oh,
visited India in
Yeah.
the Greater Noida. We have enjoyed the day of the, I think, 2 days, 3 days. He is with us.
Yeah,
Visited Agra
thank you,
and all.
Dr. Yadav.
Yeah.
Thank you.
Next year, please plan for the 27. We also invite you for that. In
We will
advance, I
see.
am
Yeah, we will
in the
see.
conference. In the conference
Yeah,
as
yeah.
well. Yeah.
Yeah, thank you for the invitation, but we will see. I love
Yeah.
to visit also the India again and see beautiful architecture and infrastructure there. I love to visit also. You should visit Philippines. Both of you.
Yeah. Okay, sir. Ketu sir, I think
yeah.
should we start?
Yeah. We cannot start.
Yeah.
So, we are moved towards the session 6. So, it's my pleasure to introduce Dr. Alan Paul L. Stibin, a distinguished academician, technologist, and research leader from Philippines, currently serving as assistant professor 4 and chairperson of research, extension, and training at Graduate School of NEU of Science and Technology. Before inviting you, sir, to take over the session, let me briefly share your profile to you. Like Dr. Stephen earned his doctor in information technology in 2024 from La Casino University, Philippines, achieving this milestone with distinct and multiple honors, including the Civil Die Awards and the Early Innovators Award. He is widely recognized for his expertise in information technology, digital governance, intelligent computing system, and computer education. His research portfolio is interdisciplinary, covering digital governance, image processing, AI, and intelligent system. Notable works include study on digital governance in Philippines University, multi-frame image restoration, and anomaly recognition in wireless ad hoc network using deep learning. Dr. Esteban has also received best paper presenter at various international conference and actively contributing to the research community by their journals and book chapters. So we are truly honored to have you with us, sir. Over to you, sir.
Thank you so much, Dr. Ketu, and also to you, my friend, Dr. Satya Yadav. And allow me to share my presentation to you so that we can start and we can rest.
Yes,
Yeah,
sir.
yeah,
So
please. Please.
how many sessions do you have today?
Sir, today
Yeah.
we have two sessions. This is the
Two
second one.
sessions.
Yes,
Okay,
yes, yes.
okay. I'll make it quick, but more learning. But I would like to separate my talk into more technical and more deep words. So I will separate my talk to that. So I'll make it light so that it will be a dessert for this evening. So I'll be sharing my presentation to you, and I hope you're able to see it. Okay, are you able to
Yeah,
see it?
it is visible, sir. Yes.
Okay, okay. Let me check the sizing. Sorry. How about that?
Yeah, it's fine.
Okay, okay.
Yes,
So
sir.
again, I would like to express my sincere gratitude for the opportunity to be part of your faculty development program. Is that correct? And
Yes, sir.
it is truly honored to be invited as one of your speakers or resource speaker today. So again, my special thanks to Dr. Satya Prakashadab, Dr. Swet Ketu, and the team, the organizing team of the online faculty development program of your department in your university, which is Madan Mohan Malaviya University of Technology. And of course, congratulations to the organizing team. It's so very hard to organize this kind of event for our faculty members. But uh, congratulations to your team. I would like also to thank the administration of your university for the invitation. So last night, while I was finalizing the content of my discussion, of my presentation today, I found myself uh, revising and changing the outline several times. Uh, and I think Dr. Satya Yadav and Dr. Ken Ketu is angry waiting for my talks. So I keep revising it. I keep changing the outline because I told to Dr. Yadav that your topic is so deep, so technical, so I don't have time to prepare for it. So I asked him if I will make my talk light and but of course related also to your um umbrella topic, but again I would like to make it light, no, not very technical, because we are very tired in our work environment. So I would love to make it simple and light, like discussion like this, no. So I keep revising it and come up with this, no. So my initial version was very technical. So there's a simulation, there's a so much words, so much uh deep words. So um but it's late evening, and we have 2 to 3 sessions today. So I want to make it light. I want to make it basic, and it should be discussions between me and to you. It's like storytelling, no? So my final topic, it focused on how to use the generative AI, which is also related to your main topic, no? How to query, how to prompt, and how to um, find similar topics, and how to construct proper prompt engineering, and others. Those are the outlines of my talk today, with the title of the role of AI in the academic landscape, because we are in the academic institution. So this to, I want to invite the AI in the academic landscape so that we can talk freely, we can discuss the concerns, the the other challenges that we encountered related to AI in the academic landscape. So um let me pause for a while and ask for this, no? Is there still a teacher today who does not know how to use generative AI tools like ChatGPT? That's the questions that I would like to throw today. Because, these tools are already everywhere. So if I'm talking about this basic AI, so probably you will be asleep. So it's already everywhere. All the sessions, all the learnings, all the technical aspects are already in the YouTube. So the reflection led me to one of my research studies, which highlights that it is equally important to focus on the thinking process and the result produced by the AI. Again, I want this topic to focus on the thinking process and the results produced by the AI, because these outputs are directly shaped by what we ask and what we instruct the AI to do. Because AI will produce output based on our questions, based on our queries. So it should be came from us. The triggering action is came from us. So I thought, why don't we focus on that? No? Why don't we focus on that team so that we can, optimize our query, optimize our prompt, optimize our questions to be thrown to this AI, which is the value of the prompt, the value of the questions that we feed into AI tools. Because with the right prompt, I believe that with the right prompt, generative AI can even reveal hidden mathematical and scientific insights that we need to learn, that we capture the insights, that we need to see across all the numbers, all the formula. So with the right prompt, with the help of generative AI, we can reveal any hidden insights with these numbers. But before we proceed, allow me to give you a general perspective on how these technologies are transforming the way we perform our daily task, which is the artificial intelligence. Because over the next 40 minutes of my talk, we will explore how AI is no longer just a tool for efficiency, but a real partner in discovery. In the last 20 years, the volume of the research has exploded. During my father's time, they need to visit the library, look for a books, printed books, and look for something that is needed in their research. To put it in perspective, more than 2.5 million research papers are published every year, meaning 2.5 million research papers are published every year. No human mind can keep up with that pace. A lot of papers, 2.5 million papers. We've moved from manual inquiry to digital libraries. And now, AI augmented research. The challenge is not just the access of these research findings, but sense making. What's the sense of this research? What's the purpose? What's the value of these research papers, which is being published online, being published on the database? AI doesn't just make research faster; it makes it smarter. Think about it. With AI, we can ask questions. We can ask questions that we never imagined before. Instead of just retrieving papers, we can ask what pattern emerged across 1,000 studies that is being uploaded to this generative AI. We can um, see the numbers, the meaning of these numbers, the insight with just correct prompt, with just correct query. What are the hidden gaps? Where is the field heading? That's so very transformational with the use of AI. Traditionally, conducting a literature review meant spending hours on keyboards, searches, and manual reading in libraries. But with AI, we are now shifting to semantic search, which is the ability to understand meaning. We are not relying on the keyword per keyword on searching on the database, but with a semantic search, which is the ability to understand meaning, not just keyword. AI can cluster themes across thousands of research papers, identify areas of concerns or consensus, and highlights where evidence is still missing. With just one click, with thousands of papers, AI can do this. This is no longer just about efficiency. This is strategic insight. Because of this, AI is now helping us to understand, conceptualize, and even clarify mathematical problems. What we are thinking, they can process what we are thinking, what we want to do, and what we want to build. AI has become our partner, our collaborator, almost like a classmate in college. But unlike that classmate who only contributed money for our research projects during our college days, during group work. This AI is truly a partner in real discovery. We now even rely on AI for data interpretation, mathematical equation, and other simulation. And again, that's not just um, demonstration of how it should be answered, but to process our idea, to process our concepts. So later, I will demonstrate to you um, in just a minute how this AI can give us a better result with a better prompt, with a better query. So again, that's not just efficiency. AI is not just for efficiency. That's strategic insight. So in just few minutes later, I'll show you AI can summarize hundreds of papers, organize them into themes, and suggest major trends and two research gaps. And this goes beyond research alone. Since we are talking about the role of AI in the in academic landscape as a whole, we are also talking about how AI has revolutionized our daily task both inside and outside the university. Outside the school community, digital transformation is already part of our daily lives, and you have experienced it firsthand. When you walk into the fast food restaurant, you are often no longer greeted by a cashier, but by a large touchscreen asking you to place your order. In many communities, portable Wi Fi is everywhere. Internet access has become simple and affordable. You just insert a coin and you have your internet. In towns and cities, e-wallets like Paytime, Google Pay, Amazon Pay, and other digital wallets are now commonly used, functioning almost like ATMs. Cash in, cash out, and pay with just a tap. And of course, there's an online shopping, which has become deeply embedded in our daily routines. This is digital transformation in action. It is no longer a futuristic concept, it is happening now, shaping the way we live, we work, and how we interact with others. So, in this era, digital transformation is not just about progress, it's about empowerment. Now, my topic focus on integrating AI or technology as a whole into teaching and research. We will begin with our learners in the education sector and focusing on how technology is transforming the norms of education. Who among us has not experienced the many creative ways of cheating in the past? Writing notes on your hands, on our clothes, or even inside our collars? How about secretly glancing at your seatmate's paper when we could not figure the answer and the questions in front of our face? And some of us may have even paid our classmate to do an assignment for us. Of course, I'm not pointing fingers to all of you, to all of us. And all of us experience this. Whether we experience them or not, those were the traditional copy paste methods of the old days. But when the pandemic began, it challenged everything, including education. It awakened and energized our tech savvy instinct, forcing us to transition into the digital era as quickly as possible. Even when our systems and applications were still immature, we pushed forward just to keep up because of the pandemic. The education sector struggled to adapt to these rapid changes, and in many cases, we were unable to control the rise of widespread academic dishonesty. Now, moving on, today is different. I know what is happening, and you know what I know. Sugar and sweeteners are no longer the only artificial things around us. Educators are now struggling to adapt to an era of rapid technological change, especially with the rise of artificial intelligence. Imagine a world where students submit essay written by AI and solve problems using tools that do not the thinking for them. Ladies and gentlemen, educators, that world that I'm talking about is not the future. It is now. As new teaching strategy begins to sprout because of this technological advancement, a new era of copy paste is also evolving. But how we can cope up with these rapid changes in education when most of our teachers and professors are from the early baby boomer and millennial generations? While our students belong to Generation Alpha, today exposure and access to technology have become the new measures of intelligence. It's not the language anymore, but the exposure and access to technology. It it became the new measures of intelligence. All of you, how do you nurture learning in your classroom? Where the majority of us were only exposed to laptops and internets and being online 24/7, which is the traits of the generation of our teachers and professors. The baby boomers, the Generation X, and the millennials. Those are the professors nowadays. Our students are now exploring automation. They are now exploring smart devices, virtual technologies, and chatbots at early age. Maybe that's why we're still relying on manual processes while they are using computer apps and algorithms to automate tasks, those new generations. Sir, mom, your students are now more powerful than we are. They are backed up by the technologies that allow them to excel in your class. Automation has become second nature to them because it's part of who they are. They are the Generation Alpha and Generation Beta. This means that any task or any assignment given to them is no longer answered with the help of the parents, relatives, but through the capabilities of AI. Students can now answer questions using voice recognitions combined with AI to provide the best possible answers real time. Voice recognition plus AI, they get real time answers without lifting a finger. They can write essay that are well humanized, that you can hardly tell the difference between the AI generated and the human generated essay. You use Google form or any form in the internet for your quiz or assignment. They have tools to scan the screen real time. And if the question is displayed on the screen, AI can instantly flash the answer in front of them. This is the new copy paste era in this era. This is not just about control C, control V anymore. It's about how technology, especially AI, is reshaping education. And sadly, not just that, all those accessories worn by your students are now their tools for strategizing. Smartwatches can now connect to the internet and functions like smartphones, allowing them to view text, to view images, and even watch videos. And those glasses, they have become the screens of the futures. These smart devices can now provide answers to any questions thrown to them real time. Please remember, technology is no longer just a tool. It's an extension of who they are. They are the new generation of this era. So the question is, are we preparing for this shift? Or are we still thinking that the students are just copying from their seatmate? That's the question. Now, what can educators do? I will just share this presentation to Dr. Yadav and Dr. Ketu so that you can read the strategies so that we can shift the concerns, the challenges into our advantage. So, rethink teaching and assessment, promote digital literacy, and encourage critical thinking. Focus on application, creativity, and personalized assignment, such as internships, hands-on laboratories, and community service projects. Teach students and teachers how to use technology responsibly and ethically. Shift from answer-based to processes. How students arrives at a solution. That should be matters more. Require them to submit drafts, outlines, and reflection to show evolution of thoughts and originality. So again, please feel free to screenshot this, but I'll be sharing the presentation to the organizer. The new copy-paste era is already here, and it's up to us to harness its potential while addressing the challenges. After all this, the fact remains. We are the educators of the today's learners. We are from the traditional generation, the time when technology exposure was limited in our lives. And our learners, the tech-savvy generation, the complete opposite of our traits. They have been overwhelmed and overly exposed to technology since birth. Please empower them because they are the next educators. They are the next teachers. They are the next professors. We've already seen the difference between this generation and we know both the advantages and advantages. We hope that the next generation, the future students of our learners, the generation beta, will experience the perfect harmony of technology access and exposure guided by our experiences. In the future, they could be our children and our grandchildren, and I hope that just like us, they can experience the joy and the brain cracking challenges we had in our younger days. Those were the days when we spent the night solving mathematical equation without a calculator, memorizing processes, memorizing formulas, scribble the scraps of paper to just get the answer. We felt the nerves when our names were called during recitation because we had to answer the question on the spot. We drew a lot, we wrote a lot, we read a lot, and let's prepare our students not just to use the technology, but to think critically and create responsibly in this tech-driven world. In the past, experts often said that the technology was a threat to education. There was even a popular saying in 2010, if teachers don't use technology, they will be left behind. And it's just a quote, and um, they don't understand what is being said here. And by around 2010, this became a reality. Computer literacy became a basic requirement for an office work. Teachers began using laptops and productivity tools such as PowerPoint. And gradually, the use of paper presentation in the old days, physical props, and handwritten lesson plans faded away. Everything became computerized. Before, we had to go to our library to conduct research. But today, with just one click on Google, we can quickly access the information we need. Today, in 2025, now in 2026, there are already predictions that by 2030, AI may partially replace teachers. At first, many of us rejected this idea, just like in 2010. We resisted using AI-generated content in our teaching method and research strategies. But where are we now? We are here, studying simulation, mathematical equation and simulation, deep learning, AI, studying about this, discussing about this, learning how to integrate AI into our work as teachers and researchers. And it's not just us. Many schools and universities already talking about this. And let us accept this reality. We are now in the era of AI. And if a teacher is not familiar with AI, there is a real possibility that students may already know more about it than we do. But the real question, the real question is this: what is the true purpose of AI for us in teaching and in research? Why do we actually need AI? What is the real value of this AI? As we all know, AI can help us process our thoughts and ideas. But the first prompt, the first question, the first query must always come from us. What if what we give to AI has no meaning or direction? Remember, the first prompt, the first question, the first query always comes from the human. AI can generate results, but the real value must come from us, from our prompt, from our query to understand things. I know that many of you already know about AI or how to use AI, how to use these AI tools, how it works behind the computer, behind this algorithm. You know, the generative AI, the open AI, other models, other large language models. Whether we admit it or not, even the younger generation already knows how to use generative AI. They know it. Other countries are now integrating AI into an elementary curriculum. But the more interesting question is this: where do you actually use AI? What research topics are you working on? And are these topics aligned with your research agenda? Does your university, the MMMUT, already have a research or academic agenda? Who here has already read the research agenda of your university? Do you have your research agenda, the focus, the priority area? Do you already read those agenda from your university? Are these aligned with the India Development Plan? How about the national priorities, the India? Have we actually read the National Development Plan of India? And how about the international research agenda? Do we know what the SDGs are? The Sustainable Development Goals? How about the mission and the vision of India? The one we call India at 2047. Are we familiar with it? Are your research topics aligned with this national aspiration? Are they contributing? Are they contributing even in a small ways to the long-term goal of your country? Because AI will always be there with just one prompt, with just algorithm. I can already give you a complete and concise result. AI is only a tool, but a value, direction, and purpose of research must come from us. It should come from us. How are we going to use this? Where are we going to use this? And how? If our research topics are not aligned with the direction of the college, the department, the region, and the nation, then we are simply wasting time and resources. Even if I spend 1 hour, 3 hours, or the entire day lecturing on how to use AI, how to use deep learning, what are the models, I am more interested in hearing your research topics and ideas and how you plan to use AI to strengthen them. Because learning how to use these AI tools is easy. That is already available on YouTube and Google. What truly matters to me is that the value of your research ideas. So let me ask, what research topics are we assigning to our students? Do these topics contribute to the vision and mission of your university? What does the Department of Computer Science and Engineering of MMMUT truly excel? Do you know it? What are the specializations of your department? What is the long-term dream of your department, the computer science department? Or better yet, your university as a whole. When people hear the name MMMUT, what should immediately come to mind? What are we truly good at? Is it in engineering? Is it in computer science? Where? What? By 2050, where do we want MMUT to be? We cannot be excel in everything, you know that. Because beyond meeting general and minimum academic standards, we must clearly define the research areas and program offerings where we truly excel. Your department should become a source of socially relevant and innovative research. So the question is, which area do we want to focus on so that both faculty and students can align their efforts in one direction? This is all about defining the long-term goals of your department or your university so that our limited resources are focused where they will create the greatest impact. According to AI, some of the major challenges in your local area, which is Gorakhpur, includes the following. This is according to AI. Flooding and climate-related hazards, because your place lies along the Rapti River. Public health and disaster risk, because your place has been known for outbreaks for Japanese encephalitis. Urbanization and environmental stress. Rapid urbanization and urban sprawl are putting pressures on natural resources and agricultural land around your place. Do we have faculty members or students who are actively focusing their research on these issues? Flooding. How many research projects of your university or your department are dedicated to flood mitigation, like prediction or management? How about the public health disease? How many research initiatives support health innovation, simulation, or data-driven solution in this area? Again, these concerns are from AI. AI knows your concern. The question is, are you answering the call of your concerns? This is the challenges experience of your university community, according to AI. Infrastructure and campus facilities. Many students and alumni mention infrastructure limitation despite ongoing development. Academic delivery and curriculum. Perceived gaps in teaching quality. Outdated or rigid curriculum concerns. Are we looking into it? Do we already have studies or policy briefs that address and help mitigate these challenges? How about placement and career support? Good to you, because according to AI, departments like computer science often report strong placement records with competitive packages. So congratulations to your department. You contributed to the vision and mission of your university. But the other programs have lower placement rates or fewer opportunities. So do we have research papers about this? Do we have projects about this? Research and faculty strength. Faculty recruitment and research funding resources can be limiting factors compared with older. Do we already have studies or policy briefs that address and help mitigate these challenges? This is your mission and vision, and I hope this is correct. The question is, how much of our vision and mission targets have we actually achieved so far? Do we have performance indicators to measure the impact of our research outputs? Do we have algorithms to quantify all these qualitatives, no, to measures the impacts or the achievements of our university based on the mission and visions of our university? When you use AI in your teaching and research work, you need to start seeing the future now. This allows you to focus your research topics and lessons designed towards where the field is heading, including your students, so that when the studies are completed and the students graduate, their research remain relevant and their knowledge does not become obsolete, because your mind, you are looking at the future. So you are already solving the problems of the future. You need to be able to imagine and create different future scenarios. That's futuristic. These scenarios will help you to design strong research proposals that directly address emerging challenges. We must learn to anticipate problems before they happen. So, futures thinking, so that we can become the leaders in developing the solutions that our country will need. Look at Israel. I will not highlight the political ambitions or others, but this is for scientific research. Look at Israel, small country, surrounded by they are considered enemies, enemy states. Yet it is able to defend itself. How? Through science. Through science. Are you familiar with Iron Dome? Thousands of rockets are launched towards Israel yearly. Yet they are able to protect their country using cutting edge technology like the Iron Dome. They will be able because they will be able to see future problems. They anticipate them and invest, focus on that because they have limited resources. So since we have limited resources, we should choose our priority where our resources should put on. And those resources will be invested into preparing for those possible scenarios or future scenarios, so that when the moment came, they were ready to respond in real time. As a researchers, we should learn how to read signals. Signals that may later turn into the scenario problems. For example, I'll give you an example. You go home. Your wife looks upset to you. Your wife slams the door and avoid talkings. What would you do? What would you do? Of course, those are signals. You need to process those signals and make a decision, make an action from that signals. Exactly with that, we learn we need to learn to read signals so we can come up with the better solutions. Now, if your wife is upset, you buy something so that you have solutions from those signals. That is what I'm talking now. So the question is, are we sensing the signals of what might happen in the future, whether in our country or in our communities? Are we sensing the signals, the future signals, or the future scenarios? There are many geopolitical signals today. Are we creating a solutions for that scenario? Do we creating a solutions for that? Our research topics align with that signals? We already seeing signals. If our research topics are aligned to that signals, are we designing studies that aim to address future problems? That's future thinking. And that is how we conceptualize research. That should how we conceptualize research. And that is what we should feed into artificial intelligence, so that they can help us. These tools helps us to process those things. Not random prompts, but well thought of ideas that AI help us to process, to refine, to strengthen our concept. How was Israel able to turn desert into productive farmland? Because of ideas, because of the minds of their peoples, because of the value they placed on the research, and because of their strong foundation in science, research, and innovation. Because the signal is they don't have farms because they have desert. That's the signals, and they build solutions. How is it possible that Israel has surplus of water and is even able to export it to other countries? How did they achieve it? These are the studies that I found from Google Scholar related to your university. So I just download some of it, upload it to AI, and create a prompt. From the uploaded research articles related to the university, extract the top 10 recurring keywords, then cluster these into thematic groups. For each cluster, provide a short descriptive level. That's the prompt. And these prompts tells AI not just to find the keyword, but to organize them into themes, just like how we should categorize literature review. And from that uploaded articles, these are the top 10 and some of the thematic groups. Oh, here is the top 10. So meaning your research papers focus on renewable energy, hybrid system, energy management system, machine learning, and others. Is these keywords aligned with the research agenda of your university or India as a whole? And based on the summary, collectively, the clusters of your research is AI assisted optimization. It's about energy, power quality, intelligent control, and other. So these are the summary insights. So this is how fast the AI process those things. Unlike before that we should summarize and get the insights from each papers. Another prompt. Based on the uploaded research, identify the major literature gaps. Highlights the areas that are underexplored or outdated. So you can ask AI about this. This is where AI shines. Instead of manually comparing gaps across dozens of papers, thousands of papers, we can ask the model to scan what's missing, what's the underexplored, and what are the outdated that we need to follow up to create a new research. So this is the result. These are the areas that are underexplored or outdated based on the research published by your university. Number one here is lack of experimental or on-site deployment result in Indian Railway. So you have a lot of research papers published, but the implementation and utilization of these research papers are lagging. So those are the underexplored. Aging power quality mitigation approaches. So the outdated aspect is these approaches do not reflect modern smart grid expectations, such as dynamic grid code. So those are outdated research findings. Remember, those papers are 2025 and it already outdated. So it should have a follow-up research paper. Limited cyber physical and digital governance integration. That's the gaps and outdated. Underexplore. Another query, another prompt. Using the uploaded articles, generate a conceptual framework showing the relationship of the university research priority areas to your place, which is Uttar Pradesh, including key drivers, barriers, and opportunities identified in the literature. So this is the conceptual flow that is being analyzed by the AI. So the key drivers are the policy, regional needs, and technology. Those are the key drivers. And the core research domains of your university is renewable energy, power electronics, intelligent control, and AI. So what are the barriers? That is the barriers of why these key drivers can't proceed with the core research domains of your university. This is simulation bias, metric fragmentation, and limited deployment. Those are the problems. Meaning you have your own problems in your university and you should address it. AI can help us to process those things, and we should um, solve or at least mitigate the challenges that is being processed, no? Being shown to us. Now, what are the opportunities? Railways, EV, electronic vehicle infrastructure, agriculture, and smart institutions. Those are the opportunities. Those are the domains that you should focus on. So in less than, I'm using AI in that way in 5 minutes. But AI helps me to understand your university, your place. AI helps me to extract the themes, the gaps, the future directions of your university. That's the power of AI. And in the manual process, that's a week, that's a months of traditional review work condensed into an actionable insights if I'm going to do it manually. And this does not replace our expertise, but it gives us a powerful starting point for smart research. By helping or by asking AI as our collaborator, our partner to process those things, to get better results. We need better result. We need better result. And you can get better result if you have better prompts. Now, I'll be sharing to you the formula or the process or the method of how are you going to construct your prompt. So I'll be sharing the technique in a PowerPoint. I'll be sharing to the organizer so that you can browse, you can read. In my module, in my learning resources, you can see the difference of the basic prompt output and the advanced prompt output based on the formula that is being taught in my module. So I'll be sharing that to you, to the organizer, so that you have time to read it. Before I end my talk, let me read this quote. Your perspective will either become your prison or your passport. Passport for your future, passport to your future, passport to your successful career, and passport to an impactful research projects that may touch and improve the quality of life of your community. Change your perspective. Don't think that you are old enough to start a new project. Don't think that you are going to retire. So leave the work to them, to the new ones. You need to change your perspective. You need to start and vibing what is being a professor be. Start with You should start with a new with a new pace of life. No, you need to see how are you going to help your community to improve the quality of life of your community, your students, and start with your project. Start with the research. You need to change your perspective. And again, thank you for listening and thank you for inviting me here. It's not about how smart AI is. It's about how smart you ask. It's about how smart you think, how to use AI, where to use AI. Because the clearer the wish, the better result. Great prompts don't happen by accident. Don't create prompts, basic prompts. Don't use AI in a way in a different wasted resources or time. You should craft your prompt, align your prompt into a better one, and you know you should know the vision mission of your university of your nation so that you can um, bring impact, you can contribute to the achievement of your university or achievement or the vision of your country. Again, this is Dr. Alan Paul Esteban. Thank you very much.
Thank you, sir. So, any question from audience?
Yes, sir.
Yes, sir.
So presentation was very good, sir.
Thank you, Dr. Perty. Thank you for your comment.
So the problems that you have discussed and what you have taken from this AI for knowledge discovery was from a particular chat GPT or which particular you have used?
Ah, prompt engineering, you can use prompt engineering in different generative AI. As long as it is generative AI, you can use prompt engineering. So you can use it in ChatGPT, Gemini, and other generative AI because prompt engineering is embedded in the algorithm of generative artificial intelligence. So they have the same structure, the same model. So as long as you are able to create your own prompt, you AI generative AI can read it and give you a better result.
Sir, someone is asked about ethical challenges of using AI tools in higher education.
Ethical challenges of using AI tools in, you
Higher
know,
education.
um, number one is plagiarism and the ethical way of getting answers or getting outputs right away from the generative AI. Meaning, we copied the output from generative AI and we make it our own. So that's the number one problem or ethical challenges in using AI in the higher education. Now, the role of the university and role of faculty members is important. That's why we are here. That's why I emphasize that we should, guide our students on, yes, you are able to use these tools, but just to enhance your idea, to just enhance, to process your thoughts, conceptualization, but not literally copy the whole output and make it in your own. We should also, um, you know, um, recognize the outputs of the AI in our papers. No, and we should recognize those things and make it publicly so that anyone knows that we are using it. No, so number one is guide our student to use the AI with ethical considerations, of course, including our faculty members, because nowadays faculty members are using AI to just create research paper, to publish, to generate reports, to generate something. So even our faculty members, we should know the limit. No, uh, we are allowed to use it, but in an ethical way.
Sir, one of the question is that how can AI enhance teaching without replacing teachers?
AI can enhance teaching in terms of processing our thoughts, processing our ideas, conceptualization, because there are things that AI produce that we are not thinking about. So by using AI, it enhance our strategies, it enhance our processing the thoughts of our students, processing the ideas of our students so that we can give better feedback to them. Just like an example, I don't have knowledge, I don't have data about your university, about your place, but with the use of I can do it in 5 minutes to gather all this information so that I can deliver the insight which is from me. So that's how we enhance. That should how we use AI to enhance teaching. Be our
उधर के ले
partner
लो
and collaborator.
फोटो.
Hello, sir. Good evening, sir.
Yeah, good evening, doctor.
Sir, my question is how can researchers use AI in academic research while maintaining their own intellectual contribution? And to what extent can the output generated by AI be trusted and relied upon as accurate, reliable, and trustworthy of use in research work?
Okay. The problem with the accuracy and the problem with the output of generative AI is because of your prompt, because of your query, because of your question. The question is, who gave the idea to the AI? Who gave the concept to the AI so that the AI have the basis on processes those things? If you, the researcher, gives the concepts, the outline, the idea to the AI, and you just need AI to process those thoughts, to enhance those ideas, well, you are the owners of those output. Now, if you will use the AI like create a full research paper about artificial intelligence. So there's no concept, there's no idea, there's no um contribution from you. So meaning the ownership is not for you, but the ownership is from that generative AI. Now, in terms of the extent of how are we going to use the output of AI in our research paper, as of now, there's no standard setup, but as long as the thoughts, the concept, and the idea is come from you, and you just need to ask the AI to process those things, to enhance, to strengthen, to conceptualize more, so that you understand more, no? And give your best insight, best discussion, then the ownership is yours. But remember, you should declare the use of AI in your research paper so that the readers are guided, so that the AI are well attributed to your research paper. So that's my answer to that question.
Okay, thank you, sir.
Thank you, sir. Sir, just to add on to that one, very good evening. First of all, I would like to thank you, sir. It's really a great session that I like the way you presented. Your whole presentation was completely, marvelous. Just to add on, one more question. So, you mentioned about, making a correct prompt. So, how do we get to know this prompt is providing the accurate result? Because if we have any problem while looking or searching anything onto the GPT or any AI tools, so whether we are getting that this particular response or the answer is accurate or not.
Yeah. Usually, I'll be giving this slide to you so that you can read all of it. Usually, we prompt AI like, please explain, AI, please create research. That's the basic prompt that we are using. But in my and in that basic AI, if the AI produce wrong outputs, we respond on another prompt, and it gives us a problem. The AI gives us a problem to process those thoughts or questions. So I have a research paper to create a formula to get a better and concise result. So I'll be showing you the formula, this one. Again, I'll be giving the presentation to you. The formula is this. Your prompt should have a context, role, action, format, and constraint. The difference of this formula from other is the creativity. So that the output of your prompt have creativity, have human nature on writing those outputs with accurate, and not in a, you know, the output of the AI is based on facts, but this enhance the output in a creative way. So there's a creative way of constructing the outputs of AI, and you should set it, and you can set it with this formula. So I'll give you one example. So the weak prompt is make a lesson plan. So that's the weak prompt. The refined prompt using the craft formula, the context is create a lesson plan. Your role, what is the role of the AI now? Is it a professor, a basic ed teacher? You should set the role. What is the action and task? Create a learning objectives, create activities. What are the format of the output? And what are the tone? And as per the creativity, you should set the creativity, like is it for elementary level way of presenting or constructing. So those are the formula that I'm being developed, and I'll be sharing the presentation to the organizer so that you can read and to know more about prompt engineering.
Got it, sir. Thank you so much.
Yeah. Thank you, sir. Thank you so much for your this AI and artificial intelligence talk. So, thank you very much, Professor Alan Paul, sir,
Thank you.
for enlightening session on role of AI in academic landscape. Your session provides us a clear, insightful perspective of how artificial intelligence is transforming teaching, research, and learning in higher education. You have given a wonderful example of triple MUT as a case study. I particularly appreciate how you explained the practical explanation of AI in academic administration and research support, along with the challenges and ethical consideration that can with it. The example and case study you have made the session highly engaging and help us connect theoretical concept with the real world application. Your expertise and clarity in presenting such a complex topic were truly commendable and will surely inspire us to explore AI in our own academic and research work. Once again, thank you, sir. Thank you for sharing your valuable knowledge and experience with us.
Thank you, Doc, and thank you, everyone. Thank you for inviting me.
Thank you, sir. Thank you.
Nice work for the organizer.
Thank
Congrats.
you. Thank you, sir. Thank you so much. So, with this, we conclude day 3, and we hope that you've all found the session insightful and valuable, and we look forward to your active participation in upcoming session. So tomorrow we have 3 sessions. So tomorrow we have 3 sessions. The first session is led by Professor Shashikant Sharma, and the second session will by Professor Rakesh Kumar, and the third session is by, I guess, Dr. Satya Prakash Yadav, sir. So there are 3 sessions. The timing is 6 to 7:30, the first session. So the Sashikant Gupta will talk about the best practices for integrating ethical consideration into academic research in AI era. And the second lecture is by Professor Rakesh Kumar, sir. The topic will be artificial neural network and model interpretability in machine learning and deep learning. And the third session that having 9 to 10. So the topic will be reward modeling in mechanistic interoperability. So we have 3 sessions tomorrow. So we want you join on time and enjoy the sessions. And if you have any and what the PPT will be shared after the the all the PPT, all the sessions will be shared to you by either via a mail or via a WhatsApp group. So don't worry about the PPTs, and happy learning. Thank you.